The classic Ruger M77. Accurate rifles and restorations, customized hunting rifle. Do you like a classy hunting rifle? Stick around to see how we customize this for a local Casper hunter. Featuring a McGowan match grade 8-twist fluted chrome moly barrel. The original Ruger walnut stock, now precision pillar bedded. A Timney 601 trigger. Upgraded David Tubbs Speed Lock CS springs, firing pin spring replacement. Ruger proprietary base/ring combination, holding this Leopold VX3i 10 power scope. Weighing in right around 8 pounds as it sits. This is a nice, light, and classy medium to big game hunting rifle. Chambered in the versatile 30-06 Ackley Improved cartridge. Handcrafted right here in Casper, Wyoming by Accurate Rifles and Restorations. Stick around for a detailed breakdown of this custom rifle made specifically for another local Casper hunter. As with any custom rifle, whether it be brand new or rebuilding an existing rig like you see here, it all starts with a discussion with a customer. Steve and I sat down and went over the aspects of what he wanted out of this rifle moving forward and what he'd like for me to do. He owns several of these M77 rifles, and he's had me rebuild 2 of them in the past and decided to have me rework this one as well. He wanted it first and foremost rechambered in 30-06 Ackley Improved. This rifle started life out as a standard SAMI spec 30-06, and he's a hand loader and an expert hunter, and so he wanted the benefits of the Ackley Improved chamber. He said he'll be shooting the 190 grain Nosler AccuBond bullets out of this thing. So we chose a McGowan barrel due to their excellent reputation and for their ability to duplicate a contour for us. We use McGowan a lot of times in these scenarios where we have to duplicate a barrel. I've used them for Savage 99s, the Ruger M77s, and other rifles such as this that have to follow a unique contour in the stock that you usually can't find going with existing contours. So we had McGowan make the barrel for us. It's pretty similar to a number 3 contour, but it is shaped to follow this. So I took the original barrel off, sent it to them, and had them recreate basically the outside contour of that barrel. So we had McGowan flute the barrel. So it's got 6 opposing flutes starting right around here after the chamber end, and then stopping about an inch short of the end of the muzzle. So my customer Steve, he's going to be shooting these 190 grain Nosler AccuBonds. So we went with a 8-twist to accommodate the little bit heavier, kind of heavier range of the 30 caliber bullet there. It's cut to 24 inches length with a half 28 thread cut on the end for any future muzzle device he wants to put on there. And it's capped off nicely with a custom knurled thread protector cap. We've installed a Timney 601 trigger for an improvement over the original Ruger trigger. This one is a nice crisp break at right around 2.5–3 pounds. We upgraded the firing pin spring with a David Tubbs Speed Lock CS spring. So that's just a modern made high performance, high tech spring. So we just went ahead and replaced that while we had everything apart. The stock is the original Ruger stock, checkered, nice walnut stock here. It was shortened to 13 inches overall length of pull from butt pad to the trigger shoe. It has a upgraded limb saver recoil pad installed, as well as it has been pillar bedded by us here in-house. The barrel channel is fully free floated, but also bedded, and we'll get into the details of that here a little later in the video. All right, so after a game plan was established, budget set, and expectations set, we proceeded to go ahead and order the barrel. Took a good few months for that to get here. McGowan's pretty busy, but they make quality stuff, so it's always worth the wait. So once we had the barrel, the first step in the operation was to completely strip down the rifle. I always do this with every rebuild. Everything's completely disassembled, like I said, detail strip down to the last pin, screw, spring, what have you. That allows us to go through everything, do a thorough parts check. We can check the integrity of the receiver here, make sure there's no cracking or galling or anything like that, any kind of worrisome maybe signs of something that would prevent us from actually rebuilding this and having it be unsafe. So thorough checks were done there. The bolt was checked, the lugs, everything like that. Everything checked out real well. We checked the springs. There are a lot of springs in this model. All the springs seem to be okay. Plus we replaced the firing pin spring like I mentioned earlier. And then the trigger was being replaced too. So all those springs didn't really matter. Then the barrel was checked. We always bore scope our barrels. We always bore scope the old ones and the new ones, the replacements. The old barrel, we bore scope just to check for signs of overpressure, any kind of damage that may be done, condition, the condition of the rifling and things like that. We're just looking for things that we could maybe suggest to the customer, say maybe he's got improper cleaning techniques, doing a little damage to the muzzle, with a cleaning rod, or maybe they're pushing their loads a little hot, so you'll see some crocodiling or fire fracturing in the throat area and stuff like that. You'll always see that a little bit, but you can always tell when it's excessive. But we didn't see anything too alarming, or really anything really alarming for that matter. Just typical wear and tear, an old barrel. This gun's been with him for decades now, and he shot it out pretty good. So it was definitely time for a replacement. So after the old barrel was thoroughly evaluated and nothing really was found of any concern, we went ahead and bore scoped the new barrel. And the biggest thing with the new barrel, we just want to make sure that the bore looks perfect, that there's no manufacturing defects or something that may have slipped past quality checks at the factory. As usual, the McGowan barrel checked out, looks immaculate in there. They do a really good job of the cut rifling process and then hand lapping of the bore to provide us with an excellent starting point for our new rifle. So the bore scoping went fine. We recorded all that information just to show the customer and to kind of cover our own butts to ensure that we're starting with a good product. Once the barrel is confirmed to be good, as it was, we take measurements off of the receiver and the bolt of the action as it is. So the extractor is removed, the firing pin assembly, all that is stripped away. So we're left with the bare receiver and the bare bolt. And that gives us measurements that we'll take off of one another to establish the thread tenon length, all the dimensions for the thread tenon, and the proper headspace dimension. We will take all that information and record it on our standard build sheet for future reference and for our records. Right, so once we have all our dimensions established and specifications for the new chamber, we go ahead and install the barrel in the lathe over here, held on the breech end by a 4-jaw chuck and on the muzzle end on the back end by a 4-jaw spider, as you'll see in the video there. So first in this process, it's fairly tedious. We want to make sure everything is aligned properly and centered, concentric to the bore as best as possible. So what we'll do is we'll start first with what's called a range rod, and that's a caliber specific rod that has piloted bushings that are fit to the bore. So that allows us to determine the exact size of the bore with as little clearance as possible. We obviously don't want a tight fit, but certainly not anything loose. So that allows us to select the proper bushing to be used for the tooling to complete the job properly. It also allows us to pre-install the barrel in the back and in the front of the lathe properly. So we will center both ends up, starting at the back, we'll center that to within a 1/2 thousandths, and we'll move to the front and kind of get that barrel spinning pretty true end to end. Then we'll do what's called centering the barrel to the curvature of the bore. The idea here is to get the chamber section of the barrel actually running true as possible, from basically the back end of where the cartridge is, or the back end of the chamber, all the way up to the throat section, where that rifling actually begins and the throat ends and the rifling begins. So what we'll do is we'll take a 1/10,000th indicator with a long probe on it, and we'll start at the very mouth of the breech end of the bore, and we'll get that centered up using the back end. So essentially the back end spider has the 4 set screws, so we're aligning that, so which causes the barrel to do the tilting motion. So we'll get that running as true as possible. Then we'll move in as far in as we can into the throat section, kind of the closest to the throat section we can. Then we'll use the 4-jaw chuck to align that radially, or axially, as it were. So we're doing both round centering and axial centering right there at that chamber. So that gives us 2 things. That gives us a perfect alignment there for the chamber to hit the bore, so the bullet, when it detonates, it actually hits the bore perfectly centered, rather than centering it at both ends, which is a perfectly good method to do as well. We just feel we like to go the extra mile here with any of our chamberings. But the second benefit is, you'll notice at the end, at the muzzle end, at the end of the barrel, that thing is spinning pretty cattywampus by the time you get everything centered. Well, that is an added benefit because it can give us the ability to clock or index that receiver to the high side of the barrel. So as that barrel spins, you'll see a high and a low spot. So we can mark on the barrel where that high spot comes up, and we'll check it with a dial test indicator as well, verifying the exact high spot of that barrel. And then wherever that lines up in relation to one of the jaws or anywhere in the chuck, we can mark T for top, essentially. And then we will be able to actually index or clock the receiver to that point where the barrel is at that highest spot. When the bullet exits the barrel, it'll be exiting basically up, giving the shooter a little bit extra MOA, a little less adjustment on the scope, a little more long-range capabilities and all that good stuff. And it's certainly better than the barrel ending up left or right or down. So that's kind of an added benefit of doing it this way. Now, admittedly, this was a little challenging for this situation because we have flutes to deal with as well. So it did end up that our top section, so we got a cut off here of the barrel of the, actually this was the barrel before we did the muzzle work, but you can see here on there is a T, and well, there's no flutes on this, but it did end up lining up basically with this flute here. So we made sure to mark that on both ends of the barrel so we wouldn't lose track where we were. Right, so we can check that periodically throughout the machining process, ensuring that the barrel is maintaining that alignment the entire time as we're machining, say turning the diameter for the thread tenon, threading operation, rechecking before the chambering section, and so forth and so on. Once we finally have the barrel completely dialed in, aligned, and ready to go, the first step is facing off the breech face of the barrel, and then turning down the outside diameter for the major diameter of the thread. I use my trusty AR Warner carbide 1/2-inch thread turning and facing tools for this operation. They work very well at a high RPM, a shallow depth of cut, and a slow feed rate to ensure the best finish and the least chance of knocking anything out of alignment. There's no reason to rush this operation. We just take nice light cuts the entire time, and that ensures that the barrel won't get knocked out of alignment or anything. So that thread tenon is turned down to a few thousandths under 1 inch. So the major diameter of this Ruger M77 is right at 1 inch. Well, you need a little clearance, so we'll turn it down to about 0.998 997, something like that, to give us a little bit of clearance for that thread. The length, calculated actual length of that thread tenon with 10 thousandths of clearance, 10 to 8 thousandths of clearance is 685 thousandths. But we don't cut it all the way. We actually leave it short for later on, which you'll see later on when we actually cut that shoulder. So we'll square it up real good with a real nice sharp cutting tool, and we'll be able to cut that and actually index that barrel to the receiver. So like I was explaining earlier, we'll be able to index that receiver to the high side of the barrel. Once all that's done, we switch up to another A.R. Warner brand tool that I like to use. It's their NV threader. It's a stand-up threader design, which allows you to get really close to a shoulder. It is, again, another 1/2-inch style lathe threading tool. So I'll go ahead and dicom, which is a blue die. I'll dicom the end of the barrel just to be able to ensure that we're actually cutting the correct threads per inch. In this Ruger's case, this M77 happens to have a 16 thread per inch thread pitch. The first thing I'll do is go in there and chamfer the very leading edge, just to give that threading tool kind of a nice little ramp to get up on there rather than a 90-degree shoulder. It also looks nice, and just kind of proper threading technique there. So we'll spin the machine up, under power, engage the half nut, and take a scratch pass, and that'll allow me to take my thread pitch gauge and verify that it's truly 16 threads per inch. Once that's known and the machine is set and running properly, we'll go ahead and do several passes over and over until we achieve the proper double depth for that thread. Close to the final double depth in the threading operation, I will start test fitting the receiver. Because you never know, especially with this one, it didn't blueprint or it didn't recut any of the internal threads, so I don't know for sure exactly where we're sitting. So we don't want to go all the way, because it's very possible that this factory produced, manufactured action or receiver is cut a little bit on the big side. So we always check a little early to make sure we have the proper fit. We don't want anything too tight because we don't want anything galling, obviously, or seizing up, but we certainly don't want anything loose. And stopping a little bit early and checking gives us that little bit of fudge factor to make sure we got a proper fit on that receiver to the barrel. Once we determine that the receiver fits properly and precisely, we'll make sure it goes all the way on, butts all the way up to the shoulder for a nearly perfect fit, especially compared to a factory chambering where everything's loose tolerances. That's what we put into these custom builds, and attention to detail and precision. We will then install a nice sharp ground, better than 90-degree cutting tool into the lathe tool holder and start machining the shoulder back to get that receiver to actually turn and clock or index to where that mark was. So we want a little bit shy of that mark to allow for the torquing of the barrel. We certainly don't want this barrel coming loose on the customer in the field, so we made sure to leave enough material there to torque that into place later on in the final assembly. So once the shoulder is machined so that the receiver lines up to where we want it, close to that flute and the index mark, we will then, a lot of times you'll have to face off the end because you've gone a little bit on the long side. Well, in this case, the stars aligned for us that day. The good Lord was looking down on us and gave us a break. We ended up right at 685. It was pretty amazing. I was pretty astounded that that actually happened. So that was a win for us that day. That doesn't always happen like that, but definitely a nice thing to achieve. So everything worked out real well there, and it was on to the next step. Once that's done, we will one last time re-verify by screwing the receiver back on and torquing it on as best we can by hand in the lathe. I don't want to take a torque wrench out because that'll make the barrel slip and lose your alignment and everything like that. But we'll get it on there as tight as we can. And we'll put the bolt in at that point and make sure it actually closes like this and has a little bit of wiggle back and forth, ensuring that there's a little bit of clearance in there from the nose of that bolt to the breech face. We do need a little clearance there, so we just double check everything there and ensure that that's properly done. As always, we'll get the indicator back in there, make sure we're still aligned, make any little adjustments that we have to do. In this case, nothing moved on us, and normally doesn't, but it's always good to check. So then at that point, it's time to work on the chamber. This is a flat breech system, so there's no reason to do any cone breech or recess breech or anything like that. It's designed as a flat breech system, so no further machining work was required on this barrel. So we can go right on to chambering. The first thing I do with the chambering is select a drill, a jobber length, just a twist drill, that's approximately 40 thousandths undersized of the finishing reamer. And that's going to just clear out a lot of that material in there, saving work for the actual finishing reamer, less wear and tear on it, and it's just a better method to do. You know, you can certainly chamber a barrel start to finish with the finishing reamer. It's just, you know, they're expensive tools, and I like to minimize any wear and tear on them. So what I've done for years and years is use a jobber length drill, just kind of clear that stuff out. And I drill in short of where that pilot's going to engage. So we'll only drill in so far, and I'll check with that reamer with the pilot installed and make sure that we still have engagement. Because I don't want that reamer coming in and cutting before it's engaged in the bore, because it can go, it's a floating reamer holder essentially. And if it's not supported by the bore, it's going to wander and chatter and do all kinds of nasty stuff. Once the jobber drill has cleared out most of the material, I'll come in with a precision boring bar and just clean up that drill hole. Drill just leaves a real nasty finish and not the best kind of way to start life with the reamer. So we'll go in there and just skim past the walls of that chamber section until it's cleared up and trued up, following the alignment that we did work so hard on. And that just clears out the chatter marks from the drill and gives that reamer a nice, real precise surface in order to start cutting on. Then we switch out to the actual finishing reamer, and we'll finish ream that chamber to headspace depth. As we approach our final depth, our calculated depth in the chambering process, we'll begin checking by screwing that receiver on and checking with go gauges. The other thing I do is we'll check before we're to the final depth. I'll be able to get in there with feeler gauges and check to see approximately how much more we have to go in order to not blow past that and really screw us up, because we'd have to take another turn off of it, screw up the alignment and all that stuff. So it's pretty crucial to get that right the very first time, every time. So what we want to see ultimately is torqued on as much by hand as we can. We want to make sure that that bolt will actually close on a go gauge with no resistance, and then have a hard stop on a no-go gauge. And that ensures that that headspace is well within SAMI spec for a safe chamber. Once that headspace is finally achieved, I go in there and actually polish out the chamber to aid in ease of extraction, get out any kind of imperfections in the chamber, and just make sure it looks real nice for the customer. Gives a little slickness when the case expands. It doesn't have any roughness, we'll say, in the chamber to get stuck on. So it will extract reliably every time. And it just kind of gives that bling factor for the customer if they ever look in there and be like, wow, look how shiny it is. All right, the breech end of the barrel is finally done. Now we get to flip the barrel around and start working on the muzzle. Once again, we'll center that barrel up. This time just centering at both ends, making sure the alignment of the muzzle end is perfectly centered and concentric with the bore. That is the last thing the bullet sees as it exits the barrel, so you want to make good and sure that that thing is centered perfectly. The muzzle end is faced off properly after it's centered up, so it will give us a fresh, nice, perfectly 90-degree square face to begin with. Then we'll proceed to turn down the outside diameter for that half 28 thread that we're going to put on there ultimately. I will turn the outside diameter to approximately 5/8 of length for that thread. I find that that gives a very good kind of optimal length for most muzzle devices. That gives the actual crown and the muzzle end of the barrel getting past the internal threads of most muzzle devices, especially like suppressor adapters and things like that. Just ensuring that that thing's not like inside, it's protruding enough to properly evacuate the gases so that it's not spitting gases out inside of a muzzle device. Once the outside diameter is turned, sometimes we'll give it a relief cut because, like in this case, I don't know what my customer is going to be putting on there in the future. So there is a very small relief cut before the shoulder of the barrel, which ensures that any muzzle device he puts on there won't get stuck, getting all the way to the shoulder and properly torquing and aligning properly. So this one got a relief cut, and then we'll proceed to thread this. In this case, we got a 1/2 thread here, standard, industry standard thread. We'll thread that down to double depth, checking with a thread pitch gauge. Once the threads are cut and verified to fit, we polish them out slightly, we deburr, we do all that kind of good stuff. Then we'll go in there, square up the shoulder again, just like we did with the breech work, making sure that that shoulder is perfectly square, 90 degrees. That allows the future muzzle device, whether it be a muzzle brake or a suppressor adapter, will properly shoulder up and be perfectly aligned with the bore. Next, with the muzzle work, I'll use my 60-degree crowning tool. It is a piloted muzzle cutting tool, so just like a chambering reamer, it has that live pilot on it that I can use the exact same bushing for this particular bore, so that as it enters and starts cutting, it's perfectly lined up. I use my Grattan Rifles reamer holder for that operation as well to ensure that everything is nice and straight as it cuts off just 1/16 of an inch or so of that internal crown. So the barrel work is finally achieved for this guy. We get the barrel out, set it aside, and in this case I made a custom knurled thread protector just to give it that kind of custom touch here. So I selected a piece of bar stock that was slightly larger than the outside diameter of the barrel here at the end. Then we get it installed in the lathe, properly centered, of course. Then we'll turn down that outside diameter to match the outside diameter of the actual barrel. Once the outside diameter is turned down, I go in there and knurl it with my knurling tool under power on the lathe there. My knurling tool is the opposing wheel style. So it's kind of like two big wheels that go in and form the knurl. So one has hash marks this way, one has hash marks this way. And it physically smashes the material out and gives a real nice medium fine knurl to the steel there. The knurling, obviously most important, gives it a little bit of grip so the guy can unscrew it, and also kind of looks cool, I think. Once the knurling operation is complete, I'll go in there with a 15-30 seconds drill to remove all the material for the tap to cut the internal threads. Once the drilling's complete, I will go in there with a chamfering tool just to give it a little bit of a chamfer to start, and also just common practice for threading and tapping. The threads were cut with a hand tap in the machine, lined up off the tailstock, so it's perfectly straight, just like anything else. But I do that by hand in the machine. It is possible to do it under power. I just feel like we're tapping less than a half inch of material, so there's really no point in risking anything there. So I'll go in there and actually tap it by hand in the machine. No big deal. All right, so we tap the threads a little bit deep, and then we'll part it off just a tiny bit longer than the 5/8 thread 10 in length here, just to provide a little protection. So the crown's sitting just a few maybe 10 thousandths inside, but it protrudes a little bit past the actual face of the muzzle to provide a little protection in case something gets hit there or gets dropped, or anything like that. All right, so once all the barrel work is all done, like that was described, I just go ahead and give it this real nice fine bee blast finish. I did speak with the customer. He likes this look. He doesn't want it Cerakoted or blued, and it's a stainless barrel, so it wouldn't be able to be blued. But we do offer Cerakote here. He really likes the kind of the dull gray look of this, like you see here. So that was all per the customer request, and we did what the customer wants. Okay, so after that was completed, it's off to stock work. So quite a bit had to be done here to this existing stock in order for the new barrel to fit and the new trigger. So this stock was previously bedded to not only the action but the entire barrel. So we had to go in there with a box end cutter and clear out all that material because this new barrel is slightly larger in diameter and just a tiny bit slightly different shape. So we had to cut all that stuff out of there and proceed to make room for this new barrel to be properly free floated. Once the barrel channel was relieved of all the existing previous bedding, we moved on to the relieving of material for the new Timney trigger. Now I'll tell you, these Timney triggers, they are quite a bit of work to get properly installed. Each M77, well, not each, but there's eras of these guns that are slightly different. There's tang safety styles and bolt safety styles. And there are several different Timney triggers that are available for each era of the M77. This particular one was one of the more challenging ones as far as fitting. You have a new safety bar on the side that requires quite a bit of wood to be removed in order for the thing to just even drop in, let alone work. The safety has a pivoting kind of bracket or latch that actually encapsulates the sear, so it'll block. It's like a sear block safety. So it actually covers and captures the sear and removes it from the actual trigger. It's a very safe way to design a safety, but that means a lot of wood behind the trigger has to be removed, and you're kind of working blind. There's really no way to see, what's going on. When you're dropping in, stuff doesn't work, so you got to just kind of take cuts. It's a lot of trial fitting until you finally get everything to work properly. The trigger itself, in this particular case, was a little bit too long. So we had to actually remove some material from the trigger in order for it to not get bound up on the trigger guard down here. The safety itself works nicely and freely, but this is also sort of a trial fitting until you finally get it to work. It started off very difficult to operate. There were things in there that were binding. And the entire time you're fitting this thing, trying it, fitting it, these triggers all the components are notorious for just falling out on you. They're ultimately contained by the stock itself, but in midair, if you tip it the wrong way or you're not holding onto things such as the sear pin and the safety bar, those things will just fall right out. So it's quite a frustrating PITA situation. I've done enough of them to know what to expect and things like that, but if you're new to installing these Timney triggers and Rugers, I'm going to warn you, they're not fun the first one you do. So just be cognizant of that and be aware it's going to be a chore. But it's very important. When you install these, you think everything's working, you have to thoroughly test it because there's hidden little gremlins in there that will cause this thing to be unsafe. So you want to make sure everything is working properly, because there's a lot of times, especially when the first few I did, you'll engage it, you'll put it on safe and play with the trigger a little bit, push it off safe, and if you just barely touch that trigger and re-engage the safety and push the safety off, a lot of times it will fire due to some interference and contact inside the stock. So be very, very, very careful if you're going to do this. So after the tedious process of getting the trigger properly installed, We took all that back out again, just get it out of the way. Then we pillar bedded this guy. So Ruger M77s are equally challenging in their pillar bedding because this front action screw is not a vertical screw. It's actually at a 45-degree angle. So it's kind of like this. Whatever engineer decided to do that should be lashed for his... No, I'm just kidding. It's really not that hard. It's just that you need specific pillars for the job that properly fit the bottom of the action and that are cut in such a way to be able to fit them in there at a 45-degree angle. Well, that being said, the stock to be cleared out for the pillars, that has to actually be installed in the milling machine at a 45-degree angle. Or you can kick your head off at a 45, one way or the other. Plenty of different ways to skin a cat, but basically we have to set that up to properly drill out the holes to accommodate the new pillars. And it's best to drill from the bottom of the stock up. That way you minimize any split out on the bottom where it's a little bit more important, because the top is obviously going to be bedded, so all that bedding will fill in any splitting that may occur there. Right, so the front and the rear action screw holes were drilled out, oversized to be able to install the new pillars. Okay, so once all that prep work was done, it's time to apply some release agent on the parts that you don't want to be permanently glued in and do some final preparations for the bedding process. We used Brownell's Acroglass for this particular job. That's a nice product. It's a resin, kind of a epoxy resin gel style. Very easy to use. It's a one-to-one mix. And it allows you to dye it whatever color you want, so we could closely match the wood color, the brown color of the wood. So we mixed that up, got all that prepared, and we literally bedded everything from the end of the barrel channel here to the back of the rear action screw. We did kind of skip this portion of it because there's really no contact there anyway with the action to the stock. But this entire section, basically from here all the way out, and then a nice area back here where that rear tang screw and pillar are. So that was all nicely bedded in place. We made sure to mask off the barrel with some thick 20 mil pipe tape to ensure that it was free floated. The biggest reason we did the barrel channel was there was a lot of cuts to do to make sure that the new barrel would fit and be probably free floated. So it just makes it look nice if the customer ever takes it off. It just looks nice rather than a bunch of butchered up wood. But it is properly free floated all the way to the end of the shank there. So the action is nestled down into the bedding while it's still wet. And then we will, in place with all the bottom metal in place, we'll lightly torque the screws just enough to get it to sit down where we want it, but we don't want to smush out any of that stuff. So to properly let that sit and cure basically for about 24 hours. Any overspill was properly cleaned up before we let it cure, just to make our lives easier and to ensure that there is no bedding permanently stuck to any of the wood parts and anything like that. Once that was done, it was off to shorten the length of pull. So we had to actually cut off about 1 inch of the existing stock here. Well, in my shop, I have what's called a Rubo workbench here. But as you'll see here in the video, I do have provisions in the bench for old-timey style holdfasts. Well, I couldn't resist. I had to break out my old-timey woodworking stuff and clamp that down with my holdfasts. Obviously protected the stock finish with some towels and things, but it was kind of fun to be able to use that. I used a hand saw with a very fine tooth in order to get a very nice, straight, clean, and flat cut. That ensured that there was no tear out at the end of the cut or any kind of unsquareness. Right, so after reliving the glory days of old, went back to modern times and broke out the belt sander. Belt sanded the end of the stock here to remove any of the teeth marks of the saw and get it basically flat. And in turn, I used the belt sander to also do the same treatment of the hard plastic spacer of the new Limb Saver recoil pad. That ensures that both surfaces are nice and flat, and they'll come together with absolutely no light gap in there when it comes to installing the pad. So cutting off the inch of wood eliminated the original screw holes for the original pad, which is actually pretty fortuitous because the new pad here, the holes didn't line up with the old ones, so I didn't have to mess with actually filling those holes in and re-gluing them and spending a day, you know, wasting a day waiting for the glue to dry so I could drill new holes. So I could immediately go ahead and find the locations of those holes, drill them in for the screws, and then attach the pad. Well, the proper way to do it, the pad's oversized from the stock, so it's back to the belt sander to go ahead and start sanding around, making quick work of removing a lot of that material to get the pad to follow the shape of the stock and to get it looking real nice like you see it here. So it's real important to follow the same lines, especially on the top and the bottom here, the heel and the toe of the stock. You want to go, you know, slowly and work real carefully in order to not, actually, you don't want to, you know, belt sand the stock itself. The customer didn't want this refinished, and we didn't want to waste a bunch of time with a stupid error like that, you know, knocking into the original finish. So slowly and carefully work your way around until we get pretty close. Once the pad's pretty close to the outside shape, bring it back to the bench, use some hand tools. I use a file to get that very last little bit, and then work my way through the grits of sandpaper for the final fitment, and doubles as kind of a polish for this plastic spacer here that is in most recoil pads. So yeah, I feel like that turned out real nice. Make it look like it's an original pad, and just a nice professional job there. After that, we took the firing pin assembly and pulled that original spring off using my custom-made firing pin disassembly tool. That tool just allows you to push the firing pin through the bolt shroud to gain access to the cross pin that holds the cocking piece on the firing pin. So that just lets you do it cleanly without holding it in a vise and scratching things up and all that stuff. So it's just a through pin, so you knock the pin out, pull the cocking piece off, and then that allows you to pull the spring off the firing pin. I went ahead and polished the firing pin real good while it was out of the gun. A lot of times these older pins are mass-produced, so they don't have the best finish on them. So the polishing just allows that new spring to slide real nice and smooth on the shaft of the pin. So it was basically reassembled it the opposite of disassembling. Real easy job. Put the new spring on, a little bit of grease, and pop that pin back in to capture the cocking piece, reassemble everything, and it's good to go with its new David Tubbs Speed Lock CS spring. Cleaned up the bedding. So the stock, cleaned up all the bedding. Any possible little overspill or whatever was cleaned up real good. Left a little material on the front or the bottom metal here to make sure that aligns every time the same way. So you'll see that there, and the pillars are both nicely bedded in there. The holes of the pillars where the action screws go in, I clear that actually out. I'll drill that out just a little bit bigger than the screws so that there's no like double thread or any binding of those screws when they're finally torqued into place. So then it's off to final assembly and testing. So a lot of work done. We did have the logo engraved, our logo, into the barrel shank. The cartridge information on the other side. But it was basically make sure everything functions properly, feeding out of the magazine. Now this rifle started life as a 30-06 and it's now a 30-06 Ackley. So nothing was altered there, so the feeding is real good. Didn't have any problems feeding, popping out. It is a control round feed with the big extractor claw there, Mauser style. But feeds into the chamber flawlessly, fires, extracts, and ejects just fine. So barrel break-in and function testing, all we had was this rifle line ball ammo. You know, it actually says on the box it's for an M1 Garand. But that's what we got to use. So it's not optimal for accuracy testing, but we used it anyway. It's all we had at that point in time. So we went out to the Accurate Rifles and Restorations Stronghold, our personal 100-yard shooting range out there, and basically laid down prone. The rifle was on bags, but we were able to have a real nice solid position just to get the scope sighted in and just do some accuracy testing just to see what was going on there. You know, we didn't expect much because obviously subpar ammunition. It's an Ackley chamber, so every time you shoot, the case is fire formed, so it's got a little bit of, it's going to be basically a lot of vibrations because it's being fire formed to this new chamber. The 150 grain ball ammo isn't the best ballistically. Brand new barrel, hasn't been broken in yet, and so on and so forth. But surprisingly, we did get pretty decent groups. I mean, there were some flyers as to be expected. But we did get a couple shots, touching each other, like almost the same hole. So even though it was pretty erratic, it gave me some pretty good optimism for this, the potential accuracy that the guy's going to get out of this barrel. It was a pleasant day, maybe 80 degrees, very little wind. So it was just a real nice day outside, allowed us to get outside and have some fun. And we did get some shots on some steel too, using a little honey locust tree as a rest. So it was a standing kind of, there's a hit, kind of a real world hunting situation, more or less, you know, using a tree as a rest. But I was able to connect with 5 out of 6 shots. The first shot, admittedly, that dang tree moved on me. So, you know, just chalk it up to that. It wasn't me, it was the tree. But all joking aside, I felt like in a real world hunting environment, like minute a deer, no problem. You know, some of those steel targets are 6 inches or whatever, and just felt real good. So all those tests went real well, flawlessly, and gave me a real good feeling to hand this back to the customer, confident that it's going to behave and perform real well for him in the field. So Steve, my customer, he's an expert veteran hunter. He's hunted for years. He's an excellent expert hand loader, so I feel he's going to be able to really squeeze every last bit of accuracy out of this. Unfortunately, I haven't delivered it to him yet, so I won't be able to include that into this video. But he's using premium components. He's got excellent reloading gear, uses top-notch, top-of-the-line powders and projectiles. And he really knows what he's doing. So previous rifles that I've worked up for him, he's been able to squeeze quarter minute of angle accuracy out of all my rifles that I've chambered for him. So I have no doubt he's going to be able to make this into a excellent shooting rifle. So I'm real excited to see the results and the outcome he gets out of this. So in conclusion, thank you very much. If you've made it all the way to the end of this video, you deserve a prize. Thanks a lot for watching. If you feel like we've deserved it, could you please leave me a thumbs up there? Give me a like button, hit there. And if you haven't yet, please subscribe to the channel. We'd love to have you on as a subscriber. It really helps show us what videos are doing well and what you guys like to see. So feel free to leave a comment as well. Do you got a Ruger M77 yourself? Would you like to customize it or just upgrade it with a nice fresh barrel, you know, we can certainly get this done for you. So don't hesitate to get in touch. You'll find all of our contact information in the description below, our website address, and at that website you can find us at the contact page. There's also links for our social media accounts. We're on Facebook, so you can get in touch with us that way as well. So we are certainly always looking for new customers. Please don't hesitate to get a hold of me. My phone number is on the website. So we not only offer the services that you see here on the channel, but we are also a consultation. If you're new to this kind of thing, I know it's very daunting. Like, there's a lot of options out there. So we can help you design whatever you're looking to get out of a rifle for your particular situation, whether that be hunting or real high-end precision bench rest or F-class or PRS or what have you. We can guide you through the process of selecting the best components for what you need based on your budget and your expectations. So we'll offer any kind of help and guidance through that process. So again, thank you very much for watching. This is Geoff with Accurate Rifles and Restorations in Casper, Wyoming, signing out. We'll see you later.